Well, how end-to-end networks. There are several tools here that are part of the work of my research team. So there's a lot of content coming from them. So autonomous self-healing end-to-end networks. Fancy title for a talk, fancy title for a set of tools, but what is it? So autonomous. The precise English definition is denoting or performed by a device capable of operating without direct human control. Self-healing, the process of making or becoming sound or healthy again. And finally, end-to-end networks, from user equipment to core functionality located at the edge or at the cloud. So that's in the architecture, and also from physical layer to application. There's always this definition of what do you mean by end-to-end network. It's from the user equipment where until the back of the network, or it's basically from top to bottom in your stack. Actually, to be precise, it's both in this case. So what exactly is an autonomous self-healing end-to-end network? This is my definition. This is the way I work, and I drive my team, the research there. It's to equip the network, the end-to-end network, with the ability and capability for dynamically self-reconfiguring and self-adapting, that's the healing, to improve performance and to meet application requirements, quality of service / quality of experience, in a sustainable manner, especially now that we talk about 6G. Big concept. I guess we all have heard the similar concept already 15 years ago. Self-organized networks. Sounds familiar? Yes, at least for half of this room, sounds familiar. Self-organized networks. And we are still talking about the same concepts. So these slides are my thoughts. So that's why I put Johann's perspective. Why are we still talking about self-organized networks now in 6G networks? I think basically because now the time has arrived to have SON, to properly have self-organized networks, which are self-healing, autonomous networks, because we have the enablers. The concept was 15 years ago, perhaps 20 years ago. Really a good goal, good concept, but we didn't have all the tools, neither the technology to achieve self-organized networks. And I think this time we do it because now we have softwareized functionality that give us a lot of flexibility, put functions here, there, move them, reduce them, increase them. So to really have that flexibility in the functions of our network. Not anymore buying several boxes of hardware with such capabilities. Now it's software-based. And that came with basically 5G. The service-based architecture that 5G brought to the picture, it's software-based. Intelligence, AI, now it's the AI era. So we have AI now. 6G, it's going to have AI natively. We are in Europe and here in the US, we are still defining what truly 6G is. But at least we can all agree that 6G has already every definition of 6G, every working group, every standardization. 6G brings intelligence by default, natively. So intelligence is here. It wasn't in the same way 20 years ago, 15, with self-organized networks. Advanced automation, certainly. We are having new processes or making new processes in an autonomous way. Coordination and orchestration. We didn't have such focus on how are we going to orchestrate services before, because networks were not service-based back in the day. They were basically we were fully oriented to connectivity rather than those services that create connectivity. and monitoring. Now we monitor everything in the network. We understand how the network is behavior. We collect data. We have been talking about data all day long, and how are we going to treat that data? So all those things together are coming together in 6G. And that's how we are going to, with 6G, we are going to have autonomous self-healing end-to-end networks. Basically, finally, the realization of self-organized networks. There's a lot of complexity. We all in this room know how the network, it's so complex now that we have a lot of different user equipment, a lot of requirements from different equipment. So connected car, it's absolutely, their connectivity requirements are so different from just our sensors, our body sensors. But still, the same network needs to manage those different worlds. We have a lot of different technologies to provide connectivity, and we have a lot of computing. And this is something that we also, in self-healing, autonomous self-healing networks, we have to take into account the computing and the storage part as part of the network. So as a matter of fact, we are, at least in my team and also in IMEC in general, we are not discussing about networks anymore. We are discussing about connected computing. So for us, a network now, it's the computing capabilities that we have all the way in the network. We have edge computing. We have computing nodes really close to the radio. Well, you know that we need to process that data. So computing has to be part of these new networks. So the connected computing, as some of us were calling it. How to manage that complexity? Intelligence comes into play. So that complexity needs to be managed by learning, by machine learning. Well, let's call it AI, but I'd rather to be more precise, machine learning. So machine learning, it's the tool to help us to understand all that data, all that complexity. And the programmability, the softwareized services are there to help us to manage all this complexity. How are we achieving autonomous self-healing networks? By focusing in 3 elements of the life cycle of a network or a network management: orchestration, control, and monitoring. If we have tools, software-based tools or software-based tools for orchestration, software-based tools for reconfiguring, controlling the network, and of course monitoring, then we are able to, in this closed loop, we are able to let the network self-organize itself, so self-healing. There are several tools. We all have tools. My team does basically 2 worlds. The softwareization, so programmable networks. We have a set of tools for orchestration, and we have a set of tools, intelligence tools, apps, or simply algorithms that are designed for a better orchestration. Software tools for control, and also software tools on intelligence to reconfigure those network components. And finally, software-based tools that we can deploy in different segments of the network to monitor the network, and actually AI-based machine learning algorithms or AI-based tools to understand that monitoring. If we combine flexibility with intelligence at every step of the loop, then we can truly have autonomous self-healing network. As part of this, we have, well, at the end of the presentation, which I'm not going to present, but it's available in the drive, we have the list of tools here, tools here, tools here. Bunch of slides that I'm not going to present them, but are at the very end of the presentation. What I'm going to present now, it's a tool that we have developed, a zero-touch network management and service Zero Touch Network and Service Management, ZSM, that we have developed in our group, and it's performing already in an autonomous way. We are capable for certain deployment that we have in the smart highway that I showed this morning. We are capable to deploy this, let it run, and the network reconfigures itself. The network heals itself. The network adapts itself by doing orchestration, control, and monitoring in an autonomous and intelligent way. And I'm going to show a little bit of that. Why am I showing this tool? Because this tool is being part of the 6GXL project. IMEC is delivering this tool, and it's going to be embedded in the DMMIA, okay, which is a bigger framework, and this is a subset of that framework. What we have used, this framework we have used in a very specific use case, or the video that I'm going to show, it's a very specific use case. Basically, it's back situation awareness, it's called. But we have done in a couple of tests in Europe. What we have done is to have a system that is, okay, the battery is not working. A system that is capable to monitor the traffic and to communicate with vehicles. And communicate what? To communicate that there's a first responder vehicle coming from the back situation awareness. And the back, it's 3, 4, 5 kilometers. So the highway opens up when you receive CAN messages in your vehicle. So it's a standardized protocol for vehicular communication. You receive the messages in the screen of your car, and then you know that in 3 kilometers or 4, you look back and you don't even see the first responder, it's coming. So you open the path, and that's how the ambulances just cross the highway without even using the siren, because electronically everyone knows that it's coming. So to do that, we have the different edges in the highway, as I showed you this morning. And every edge is managing this service. These services, we call them edge apps, but imagine that it's an X app running at the edge. And while the vehicle moves, of course, the edge also, this service needs to move through the edges. How do we do that if the edges are in a different domain? If perhaps they are from a different vendor, from a different operator? How do we transfer that? There's a lot of research behind that in how to optimize this in an autonomous way, and also in an standardized way, communication between edges, but I'm not going to talk about that. So imagine that every edge has an orchestrator. It knows their services. It knows the capacity of the edge computing. It knows the latency. But then we also have a cloud, a higher entity orchestrator. So that's the use case. And the zero touch management, zero touch network and service management. Basically, it's a concept of automated orchestration of network resources that uses these techniques that I was mentioning at the very beginning, all these tools. It's already standardized by ETSI, so it's not just a concept. Actually, it's a standard that it's being implemented, and we have one implementation of it. The basics, the foundational technologies are in all this chain. I'm going to go faster. So all these capabilities at the edge, we need edge computing, certainly, softwareization of the functions, softwareization of the network, the core and the run and the core, and the intelligence behind. For every single step, these are the building blocks that we are using, and that actually they are available through our ZSM system. This is the specific implementation that we have done. We have different edges in the smart highway. These boxes, they have high computing capabilities. So we have an edge deployed for this use case, every 600 meters to test. We have different smart vehicles that are capable to communicate with the edge, with the application running. In general, this application will move through the edges, and we are having network measurements of everything: the vehicle, the network of the vehicle, the distance in latency to the next edge. I'm going to show you in the coming slides. All of that managed by our different tools on top of or tools as part of the zero-touch management. We do measure things in the loop. We do measure things. We orchestrate, scale up, scale down the edge, the system. We take decisions on how the service should be running to provide to fulfill the requirements of this vehicle, for instance. So we have to take care on the scalability, how we transfer the information, the computing. Oh yeah, we measure that, of course, at every edge. Is this edge the right edge for the application? Distance, well, latency-wise or computing capabilities-wise? If not, can I increase the capability of this edge? If not, I move to the next edge. And that's everything in an autonomous way. So there's no human intervention once you have the system running. So every edge has the AI embedded. We have requirements specific for the use case. We have an edge orchestrator, and we have a global orchestrator on top of them. In this case, there's a need of hierarchy to see from a higher level all the performance. A big overview, a quick overview, it should be, we collect the data, we monitor, and to do the monitoring, well, when we set up, we use intents. Georges explained about the intent-based networks earlier today, so he did the job for me. But basically, it's a format that you say, I need this, this, and that. And you have no idea what's behind on the network. You just release the intent, and the network, the autonomous network, should set up the rest. What resources, as a network, what resources do I have? I deploy them for the intent. Then we have the intelligence, well, NIFs, the network intelligence functions, deployed along the network. We take decisions. We do the operations. This is in an autonomous way. Understand the performance of the network, the performance of the vehicle, the latencies, the requirements, and then we scaled up, scaled down, move the functions or whatever needs to be done. There's a decision taken based on the information that was collected. So this is a well-informed decision that the system takes, and then we just execute them and keep things running. And this is automatic, no human in the loop. So now I'm going to show you two videos and showing you how it works. In the use case, we had two scenarios. So for the same vehicle, for the same network, we have two scenarios. One, it's high demand. We need to scale up the system automatically because we need, it's for a mission critical, so we need to reduce latencies. Therefore, we need to perhaps increase capacity at the computing or simply transfer the whole application closer to the vehicle, so to the next edge. Whatever it needs to be done has to be done in order to deliver a mission critical connectivity for this scenario. The same network with the same vehicle. Then when this is not anymore demanded, we go to low traffic, as we call it, and we reduce the computing. So it's energy. Here, unfortunately, you consume a lot of energy. In your constraints, you don't have energy as a constraint. You have communication because this is a first responder connectivity emergency. Not anymore. Same resources, same network becomes a greener network, less consumption, less data transfer because there's no need to keep those resources running. We do that in an autonomous way. This is the scenario, the Smart Highway E313 in Antwerp. And we have edge, 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 and we have a vehicle running from here to here. These are the vehicles you saw this morning. We are measuring the distance, well, the latency. Unit, what is the capacity of this roadside unit? Is it loaded, etc., etc.? And all that information that it's fed into the orchestration, all this is info, and the orchestration takes a decision based in deep reinforced learning in this case. Our very first initial case was rule-based. Now it's everything with learning. And we take a decision and we execute it. Basically, quickly, the intent, we receive the intent, and the decision will be, in this case, to instantiate at the edge, to instantiate services, to scale up, to migrate from one edge to another, or simply to just stop the service because you don't need to consume energy because you don't need the service anymore. So these things need to be really, really autonomous. These are the 7 roadside units. So basically, MECs, G-Node-Bs with MECs here. This is the information in real time that we are getting about the status of every edge, the CPU, the load, the memory capacity, the computing part, the connectivity part, and the geographical location, because this is a vehicular system. This is connected computing, as I was mentioning at the beginning. All of that we need to understand to take right decisions. Let's put play for the first video. I have another one, and with that, I guess I'm going to reach my time. So here, basically, we are monitoring every edge, and we can see what's the status of every edge. So every roadside unit edge. Now, this is the demo. This is basically how the intents are. The deployer publishes an intent. The intent says, I need this capacity on computing, on memory, on latency, on storage, because my application requires this. This is everything. Once you have the intent, this is automatic. Then the orchestrators at every edge, they subscribe to this information. They start sending and collecting data from the network. And these are the metrics that are being pushed. So this is the monitoring side with intelligence. Then that information goes to the decision maker. The decision maker sees every edge, takes an informed decision. This one is with deep reinforced learning. And finally, this gets pushed back and gets executed. We select this roadside unit, increase, decrease for the edge computing number 3, let's say, and voila. So that's how basically works. Let me go to the last slide. No, sorry. This is the last slide, and I should put the video in the middle. It's running? Yeah, it's running. I don't know if it's running. Come on, sorry. Okay, so basically we are checking if this is the high demand, so first responder situation, and then what happens if it's the other situation, the greener network, less computing, less usage. So we start checking and taking decisions which roadside unit should be. So it took a decision, changed to number 7. If we look into every roadside unit, we have the vehicle moving in the highway, we have the computing capabilities, and for every roadside unit, we are taking measurements, and then here it's coming the decision. The decision, it's telling which roadside unit you should connect and why, because of the computing, because of the latency, how it increases, decreases, and this is everything autonomous. And that was my last slide. And are we there yet? I don't think we are there yet, but this is a very big step for achieving autonomous self-healing networks. We have automation, we have intelligence, intent-based networking. It's the future, right, George? And understanding the network exposure measurements. Thank you. If there's still time, I'll be happy for
questions. Okay.
Yeah, thanks very much. What happens if the network is not possible to answer your request, so to say, if it cannot fulfill the intent that you formulated? What happens?
Basically, like admission control. In admission control, usually, if I cannot get this user equipment, I cannot serve this user equipment, I'm not going to even let him connect. That's supposedly that's how it should be. It's a simple admission control. If I cannot fulfill you, when I get your intent and I know I cannot fulfill it, I'll reject it. This network cannot fulfill your requested service. It can suggest, that's what we did, an experiment. It suggests, I have this performance I can offer to you. If you change your application requirements, then I can serve you. And that was our first trial of having network-aware application interacting with an application-aware network. So we have done that, but that's just one approach of my team.
Well, before self-healing, we have to have zero-touch management.
Yes.
Do you think that ZSM will bring us close to that?
Yes, I'm convinced.
Okay.
I'm convinced. There's a cost of running a zero-touch management and ZSM. There's a computing cost for it, but nowadays with the computing capabilities that we have all over the network, we can afford that cost.
Okay, thank you.
So, I was going to ask my question, but we've got a lot of questions here. Huh? No, no, you go first. You go first.
Hello, hello. Johann, thanks so much for presentation. I have one question about your intent-based networking, right, and resource management. When resolving the intents, right, and deciding how to locate resources, how would you deal with ambiguous solutions and or alternative ways to fulfill those requests, right? How would
That's a good question, because usually you assume that the intent it's very objective, and I need this, you deliver this. We didn't look into that, but we have discussed about that in different circles that are promoting intent-based networks, and there's a trend on making sure that you get rid of ambiguous or subjective requests by defining the form, not only the format, but the semantics on how you write your intent. And if you basically, I don't want to say constrain, that's in this case it's a negative connotation of saying you constrain the way you express your intent. But basically, if you standardize the intent and the semantics in that intent, then we will avoid this situation. But so far, the intents have been sharp.
So as someone who has spent almost my entire career working on this, and you mentioned the original autonomous networks efforts, right? So I was back in Bell Labs trying to do that and discovering just how hard it is. And one of the things that we realized back in those early days is you can't really work on this until you have what you've built here, I think. You need a system to study, right? And I think, to me, the really interesting thing here now is, and I think this is what you're alluding to, is that, are we there yet? Well, no. But now that you have this, how do you break it, right? And I think there's a million different ways to break it and a million different problems to solve then to really make it work so that the network operators will start doing this, yeah?
Yeah, that's true. And some discussions that we had at IMEC, at the research center that I work, when we talk about impact, well, I have to be honest, when we talk about valorization and impact, we say, how is this going to really impact telco operators? Because now it's like competing with the Nokias and the Ericssons. They do have the whole solution. Well, not an self-healing and autonomous solution, but they have a complete solution that they provide for a service to the operators. And me as an operator, I'd rather to pay for such solution and get my network running. How do we make this solution that is complex? How do we make it attractive to be adopted? That's one of our questions that we are discussing in the center. But something that always comes to these discussions is openness. If we make sure that the different components, because as I show you, it's a set of different components together. If we make sure that these components are open, and they can even be, it can be plug and play, not necessarily by our components, but some other vendor components, yeah, like Open Run. You get new vendors into the game. If you get other tools that are equally compatible and useful, then you can enhance the ecosystem. You can motivate the ecosystem to adopt these solutions, not ours, but basically you can create your own pick and mix. So how can I say this? Mix and match solution of this one. I think openness is going to be the way we can motivate the community to adopt this.
But even I think we need these tools like you built here to start to hammer away on the research problems and discover new research problems associated with that overall system that we didn't know were there until we had a system like this to work with. Yeah.
Yeah.
For autonomous control, really.
Yeah, but I think now's the time, as I said, as I like to start my discussions, the concept is old, and you can be sitting and listening to me like, oh yeah, yet another talk on these things. But now are happening because now we have the tools.
Yeah.
5G, 6G brought that.
Very
Okay.
good. Okay. Thank you.
Thanks to you.